Now imagine we are talking about inheritance in C++. And so imagine a very simple case where you've got a base parent class and the parent's child is a class called 1. So the parent child is being inherited by this child class, which is called 1. And imagine that this is the case. How will you implement this? Let us just see this. So now this is a part of a big program. So we'll just see this much first, where we have a base class. Look at this class base and look at this class 1, which is coming from base. Now what is this base class? It just has a public variable called int base variable, and a virtual function called virtual void set base var equal to 0. Now what is this? Let me explain. Basically this function is there to mean that the class base is not to be made into an object, because you see we are not going to just use class base anywhere. We are going to just use it for inheriting certain properties into other classes, which, that is, the classes which will be derived from it, the classes which will inherit from base class, only those will be made into objects. Class base is not going to be made into objects. So this is such a class. It's an abstract class. Abstract classes are like this, where at least one of these functions are set to be 0. As you can see, where the cursor is blinking, this particular area, okay, this function has been set to 0. This one here, this particular line, as you can imagine. Now that makes the base class, which is this class, it makes it into an abstract class which cannot be made into an object. We can only inherit from it. If there are any static methods inside it, we can use that, and so on and so forth, but we cannot make it into an object. Now the point is that such classes are useful for situations where, for example, you have a basic shape class which can be taken into which can take various forms, but as such shape doesn't have any value. So we come to a situation as follows. Imagine that this is a shape class. Now as such, the shape will have things like dimensions, it will have things like area or surface area. Okay, so you'll have things like area, surface area. Now you see these particular things, they will be inherited by all shapes. But if I tell you, give me a shape, okay, that actually doesn't make any sense at all. Well, the reason being that what is the shape, you will ask. So obviously it doesn't make any sense. However, from the shape class, you can have several other classes, like you can have a circle class, you have a circle class, you can have a rectangle class, or more specifically, you can actually have a, if I have to be more careful, we can have an ellipse class, and this ellipse class can be further made into a circle class. A circle is a special type of an ellipse, and you can have a non-circular ellipse class as well. So like that it may go on. Okay, then you can have another shape called triangle, which again does not make any particular sense unless and until you want to specify whether it's a scalene triangle or whether it's a right angle triangle, or whether it's a isosceles triangle, etc. So like that. But in all cases, you see, the shape class itself doesn't make any sense. What it is there for is to provide it with certain very common functions. So this is a, let's say this is a function. So let's say that this is actually a function. Okay, this is a function, let's say, and okay, and these are the dimensions, etc., are the attributes. Okay, so these can be provided to all the shapes that are coming after it, but as such, a shape itself doesn't make any sense. So how will you make an object of shape? It doesn't make any sense. So how will you make an object of shape? So basically we can make this into an abstract class. Like for example, this fn area, or fn surface area, we can turn this into a 0. Okay, so when we turn this into a 0, shape class automatically becomes an abstract class. But we have to take note of the fact that fn area has to be protected. So fn area in the shape class, this has to be a protected function. If it is not protected, if it is private, it will not come to the other classes. It can be public, but it doesn't make any sense. So it can be protected, then it will come to the other classes, but it cannot be private. Okay, so it can be protected or it can be public, but it cannot be anything else. It cannot be private. Remember that if you leave it without any qualifiers, then fn area by default becomes a private function or method, and it doesn't come to the other classes. So you have to take care of that. That as well as these dimensions also, they also will have to be protected or public, but public doesn't make any sense. So protected, not private. Now the dimensions, now basically, so when what will happen is that once this comes out, okay, once this fn area equals to 0, this comes into these classes, what will happen is that if for any reason you fail to redefine fn area, which is called overriding, if you fail to redefine fn area in any of these shape classes or subclasses of shape inherited classes from shape, then that particular class will also become an abstract class because it will inherit fn area equal to 0. So what I mean to say is that fn area equal to 0 comes from shape to triangle to ellipse to rectangle and then to its other class, the subclasses as well, which are the grandchildren of shape. So this is the child of shape, this is the grandchild of shape, like that. So it will come to the children and the grandchildren, and what will immediately happen is that if you do not in any of the classes, especially this class for example, if you do not redefine fn area into a proper function, okay, it remains as fn area equals to 0 in triangle also, or in ellipse also, or in rectangle also, thus making triangle into an abstract class, ellipse into an abstract class, and rectangle into an abstract class. Now coming back to our program here, as you can see, so we've got class base and the class 1 has come from it. Class base has got no other particular value other than being able to be inherited. So we're not going to make any objects of that. So we make this function into a virtual function and set it to be 0. Now we inherit this into class 1. So class 1 public base. What is public base? This refers to public inheritance. What is public inheritance? Public inheritance means all the public variables and functions, in this case baseware and set baseware both, will stay on as public in class 1. What would happen otherwise? For example, if I did not have this would actually be a private inheritance. So everything would become private. If I only had this, what would happen? Then the protected variables and functions would stay on as protected variables and functions. The public functions and variables would also become protected. But we need to access setVar, for example, from an outside context by using the member of operator. Hence, we cannot afford to keep it protected. Otherwise, we won't be able to use it. So, we make it public. Okay. So, this situation is summarized as follows. So now, if you look at this class, this is what I've done. So class base, and that was there, and then class 1 is getting the public inheritance from base. Now inside it, I have created two more variables, int_var1 and int_var2. They're protected. Remember that in this, the baseware variable has come in as a public variable. You won't see it obviously here because you're not writing it, but when it will be compiled, the baseware will be available with the objects of 1. Baseware of the base class will be available with the objects of 1. Now, to stop 1 from, that is the class called 1, is to stop it from becoming a virtual class, an abstract class. I have, as I mentioned before, I'm overriding the set baseware variable. Then there is a constructor called 1, a default constructor that is non-parameterized, and then there's another one called printvar. Now let us look at what the functions are. These are all public functions. Set baseware 1 and printvar, these are all public functions. Now let's see what they do. So in set baseware is set to 99. And in 1, set baseware is called, that means it will set the baseware to 99. Int_var1 will be set to 56 and int_var2 will be set to 65. And then printvar is going to be called. And what is printvar? Printvar is basically 1, baseware is the value of baseware, int_var is the value of int_var, and int_var2 is the value of int_var. That. Before we go on to the other classes, then let us look at the main function, how it is working. Now let us now here, okay, create an object of the class 1 called 1obj1. So if the class 1obj1 is created, obviously default non-parameterized constructor is going to be called, which is this. It's called set baseware, where the baseware that it receives from the class of base will become 99, in var will be set to 56, in var 2 will be, in var 1 will be set to 56, in var 2 will be set to 65, and it will all be printed by print var. So let's run it. There, as you can see, one base var is 99, int var 1 is 56, and int var 2 is 65. As it says, int var 1 is 56 and int var 2 is 65. That's what it says. Okay, so this is the result of instantiating an object of 1 . And you can easily see what is going on here, that the set base var is being overridden, and you can see that the base var object is a base var integer variable is actually from the class base. It has not been declared in 1. So how am I being able to set base var? Okay, I'm overriding set base var, so that is there, but how am I being able to set the value of base var when the base var has not been declared in 1? And you are seeing the result. See, you're already seeing the result here. There, this 99 here, this one here is actually of that. Okay, so this base var is actually coming from the base class. This shows the inheritance. So this is called single inheritance, one class coming from another. Okay, now my friends, see this situation very clearly, very carefully. What we have here. Now, when 1 came from base, this is called single inheritance. Single inheritance. Now we are looking at 2 also coming from 1. So, sum of 1 will be coming into 2, whichever is protected and public. Private ones will not come. From base, some have come to 1. Those which are protected and public, and those will actually come into 2 also. From 1 it will come into 2 also. Once again, the inheritance rules of private inheritance, protected inheritance, and public inheritance rules will be followed here. So this 1 will get set base var. From base it has already got it, we have run it, so that is there. It's got another print var which we have seen. It is printing the variables. All of this we have seen. In 2, what we'll do is we'll have int var and int var 2, int var 1 and int var 2 coming from 1 to 2. But we'll make an overridden local copy of 2. So we'll override int var 2 in 2, so that int var 2's value will be the local copy and not the one that it is receiving from 1. We'll show that in code in a bit. And constructor 2 is there. Let us now see the implementation of this multi-level inheritance. Okay. So this multi-level inheritance with these functions and these attributes which are local, okay, to override the int var 2 from 1, this local copy of int var 2 has been created, and the print var will come from 1, and 2 is obviously the constructor of 2. Now we'll see how that plays out. So have a look. This is the class 2. Okay. Public 1. Once again we are having public inheritance. So protected will remain protected. Private will remain private. Private will not come. Beg your pardon. Protected will become protected. And public will remain public. So what are the public methods and stuff that it is receiving from 1? It is receiving set base var, which is coming actually from base var, which is actually coming from base, receiving int var 1 and int var 2 directly from 1, and it is receiving print var, which is also directly from 1. But here I'm also doing something. I'm making a local copy of invar2. Now in the constructor 2, I'm setting the local copy of invar2 to 31. Remember, in 1, the local copy of invar2 in 1 was set to 65 here. That is, the 1's copy is set to 65. In 2, the local copy of invar2, not the one it is receiving from 1, is set to 31. Now printvar is called. Printvar obviously is called upon the indvar1 which is received from 1, the basevar which is received from base through 1 again, and the invar2 which is not received from 1 because that is suppressed now. That is suppressed because we've got a local copy of invar2 inside the class 2. So the class 2's copy of invar2 will be printed. That is, instead of 65, 31 will be printed. So we go to main and we release the comments here. And we're going to put some comments. Out here so that we don't, for the time being, we will not be doing object 1. Well, okay, let us do object 1 and let's see. Done. So you see 1 base var is 99, int var 1 is 56, int var 2 is 65. Okay. 1 base var is 99. So basically this is coming from the 1. The 1 object, why has it been written so many times? Because when you are receiving, first of all, you have actually made a 1 object, but then when you are actually making the 2 object, then it is based on the 1 object, so that is also created. You might wonder, in that case, when invar2 is 31, why is printvar not printing 31? Instead, it is printing 65. See, the first one is for obj1. The second one is for the 1 of 2 and the third one is of 2 itself. In this case, base var is actually coming from 1. It is coming from base, but it is coming through the object of 1. Invar 1 is directly coming from 1. Invar 2, this one, why is it 65 and not 31? But that is because the print var, which is printing the base var and invar 1 and invar 2 has not been overridden. So this remains the method of the superclass 1. That is why it is taking 56 and 65. Let us now do this. Watch carefully. I am now going to make a local copy, a protected copy of print var here. So see, I am making live this print var, and this print var here looks like this. If I leave the comments here, and this is the print var of 2, not 1. This is the print var of 2, not 1. You have seen. Okay. So we are overriding print var. Now because we are overriding print var in 2, the object of 1, which was a superclass of the class 1, is actually a superclass of 2. Base gives rise to 1 has come from base, but inherited from base, and 2 has inherited from 1. Multi-level inheritance. So we've already seen that this is happening, that from 1 we are receiving all these as we are shown in the diagram, okay, which is basically this diagram here. We've already shown how this set base var and print var and everything is playing out. We have copies of int var 1 and int var 2 being printed out in 2. In the context of 2, we've already seen this. So that is obviously there. Now you see, but what we have to do is we have to make some local copies. That is why we have not only done int var 2 equals to 31, we are now creating a local copy of print var 2 also, so that this 31 is reflected. Because if I didn't do this here, then this print var would have come from the superclass A, and the superclass A's print var actually, as you have seen, prints out int var 2 to be 65 because it takes the int var 2 of its own object. Now, because we have redefined print var, we run it. See the difference. Notice the difference. See, int var, as opposed to what was happening previously, int var 2 here is 65, int var 2 here is 31. This one here, 31. See the difference. The 65, if you can look up, okay, run again. The first set of values is of object 1, obviously. Second one is the object 1 from 2. And the third one is the object 2's variables. Base var is still 99. It is coming from coming from base via 1. Int var 1 is 56. It is coming directly from 1. Int var 2, which was 65, as you can see in 1 it is 65. It has been overridden to 31 in the context of 2. This is how multi-level inheritance is playing out. Now we come to another type of inheritance. We have a class 2, which is coming from 1, which is again coming from base, and we'll take another independent class called 3, and we'll inherit a fourth class called 4 from class 2 and class 3. Okay, this is called multiple inheritance. And also, because this side is involved and this side is also involved, this is also called hybrid, okay, inheritance. So that means there is single and multi-level inheritance on one hand, multiple inheritance on the other. So because it's a mixture of all these inheritance, it's called multiple inheritance. Let's look at the implementation of that. So this is the class 3, very simple class once again, having got just a protected method called fn3 and a public constructor. That's all. What does the constructor do? It prints out that it confirms by printing out that it is an object of object 3. And what is happening with fn3? fn3 just prints out that it is this function 3fn3. That's all. It is a protected method. It can be inherited. It cannot be called directly with a member of operator, that is the dot or narrow operator, etc. Now with 2 and 3 in place, we now have a multiple inheritance, in fact a multiple level plus multiple inheritance, which is a hybrid inheritance of class 4 like this, deriving from 2 in a public way and 3 also in a public way. It would be highly possible, 3 public, it would be highly possible to make any one of those anything else. For example, we could have private 2, protected 3. We could have public 2 or then private or protected 3, like that. Combination can be there. But this is how you write it. This is a syntax. And here we are making 4 as free as possible. So what is in there? Constructed as usual. And then nothing else. So if the constructor is called, it is calling print var. Where does it get that print var from? This print var, obviously it is receiving from 2, because it comes from 2. Where did 2 get it from? 2 got it from 1. So it is the new inheritance ladder that we are seeing here. Then we call the fn3, and you can imagine fn3, where does it get fn3 from? There is no fn3 in 4. It gets fn3 from the class 3. And so we now go to the main. Now we release these following codes, which were kept commented for convenience. What we're doing here, 1 object 1, then we're declaring char weight, 2 object 2 once again. So the constructor will be called and all those stuff, calling out the functions, print var, etc. will be done. Then we again wait. We again put in input for wait. Why do we input for wait? Because while we are inputting, we can wait and see the previous result. Then 3 object 3. This is the same function as getch basically. Now 3 object 3. Okay, no problem at all. And then we have, so we are printing out the results. This one here. And then we are finally calling upon an object of 4, which basically we will be creating an object of 4. In that case, we are calling the constructor, and the constructor will do this work. What is the work? Print var is called, and the very fn3 is called. So if I run it, see what will happen. Okay, so up to here we have already done. First one is just the object of 1. The second one is the object of the 2 object. The one object that is made for making the 2 object. The next one is the actual 2 object. Now let us input something for weight. Object 3. See, object the 3 constructor is called. Object 3 is printed, that it is object 3. Now look, see, 2 base var is 99. So now we are, after object 3 is being printed, after this one here, see, from this particular place to this here, what we have done is we have actually from here, say from where 2 is written, okay, from here to here, these sort of 4 lines here. So 2 base var is 99. See, in 2 we made base var into a 99. That was actually in a very old base object. We cannot help it. Int var 1 is 56. As you can imagine, it is coming from 1. Int var 2 is 31, which as you can imagine is the overridden int var 2 of the class 2. And then 3 is also called, and the fn3 function is called, which just prints is fn3. To make it a bit more simple, I will just be a smart cout Actually, I'll just give a code close, and I was trying to give it a, never mind. And okay, now run it. See, up to 2, and now for the others. Okay, I'm class 4. So object 3, you can see from here, I have indicated that I'm class 4. It's actually in class 4 now. Class 4, and from 2 the base var is being received. That is also clearly indicated. From 2 the base var is being received. And int var 1 is 36, that is from 1, but int var 2 is 31, which is a local copy of the 2 from which the 4 was made, which has also been made from copies and stuff of other variables as well, but there you are. And the function fn3 obviously belongs to 3, definitely. I don't expect it. So 3 3. I don't expect it to be anything more complicated than just this, which is just indicating that it is there. Because we're trying to see how things are coming live in the sub classes, and so we just need to see what is there. And so this 3 fn3, as you can see, when we are calling the fn3 function, all we did in there was write it is fn3 just to indicate the control flow, and it is there. So friends, this is all about the various different types of inheritance that you can find. So we'll talk more about, but inheritance is the bread and butter of the object-oriented programming. In a data encapsulation, hiding, and inheritance, these three are the bread and butter of object-oriented programmers. And so we'll see more of this as we go along, carry on with the topics further.